Okay, we are continuing with linear programming where we are looking at mathematical models. So this is our second example. So we have a carpenter intends to manufacture at least 10 tables and at least 20 chairs. Each table requires 4 hours of assembly and 2 hours of vanishing. Each chair requires 3 hours of assembling and 1 hour of vanishing. There are 240 hours for assembling and 100 hours for vanishing. Given that X represents the number of tables and Y the number of chairs, write 4 inequalities which represent these conditions. So we need now to come up with 4 inequalities representing the conditions that we have been given. So those inequalities are what we call mathematical models, which are formed from conditions in a problem. So the conditions in this, the condition and the problem that we are given is this statement that we have just gone through, that we have just read. Okay. So now we have, let's see where the models are going to come from. A carpenter intends to manufacture at least 10 tables. So we have the first statement. So we have the first statement, we have at least 10 tables. At least 10 tables. So from this condition, we are going to come up with our first inequality. At least 10 tables. Tables are being represented by X. So at least 10 tables. So we have X, because tables are represented by X. So we have X at least 10. At least means greater than or equal to 10. So at least 10 tables. Tables at least 10. X are tables. Greater or equal to means at least. And also we have 10. Okay, so that's our first inequality, at least 10 tables. And the second inequality will come from this statement that we have here, and at least 20 chairs. This one here, at least 20 chairs. So chairs are Y, chairs are Y. Then we have at least means greater than or equal to, then we also have 20. So the second inequality will come from at least 20 chairs. Then the first inequality came from at least 10 tables. Okay, so we have 2 inequalities for a start. Okay, let's see where the next 2 inequalities are going to come from. Each table requires 4 hours of vanishing, 4 hours of assembly, and 2 hours of vanishing. Each chair requires 3 hours of assembling and 1 hour of vanishing. Okay, so from the issue of assembling, we need to come up with the inequalities from assembling and vanishing. Okay, we have assembling. From assembling, we are going to come up with a set of inequalities, and from also vanishing, we are also going to come up with a set of with 1 inequality. So assembling, let's see what the statement has told us about assembling tables and chairs. We know that X are tables, Y are chairs. Now let's see what the condition is telling us about assembling and also assembling the tables and chairs. So we are told that each table, so table is X, requires 4 hours of assembly. So assembling the tables which are X, we have 4 hours. So let this 4 multiplied by X. So for assembling 4 hours per table. That's for assembly. Each table requires 4 hours of assembly and 2 hours of vanishing. So on the side of vanishing, we are also vanishing the tables and the chairs. Now we are told here that each tables are X, requires 2 hours of vanishing. So vanishing the tables, it's 2 hours. Okay, let's now look at the chairs. So for assembling the tables and assembling the tables and vanishing the tables, we have this. Now let's look at it now. Vanishing the tables, vanishing the chairs now. Yes. So we are told that each chair, remember, chairs are Y. Chairs are Y. So we are talking about assembling the chairs, also vanishing the chairs. So we are told that each chair requires 3 hours of assembling. So assembling is here. Assembling the chairs are Y. Now we are told 3 hours of assembling. So we have 3 hours of assembling the chairs. Each chair requires 3 hours of assembling and 1 hour of vanishing. So vanishing the Y, which are the chairs, we have 1 hour. So we don't say one Y, we just leave it the way it is as Y. Okay. Now, let's see now the time available for vanishing and assembling. There are 240 hours for assembling. So assembling here we are told 240 hours. And 100 hours for vanishing. So vanishing here we are told 100 hours. Then finally we are told to say, given that X represents the, okay, this is now what we are looking for. So for assembling the tables plus assembling the chairs, the number of hours available are 240. So meaning that this is the maximum here. This is the utmost here. So maximum utmost means less than or equal to. So this is our third inequality. This is our third inequality. Okay, so this is our third inequality. So vanishing here, we are talking about vanishing the tables and the chairs. The total amount of time available for vanishing is 100 hours, meaning that this is the maximum number of hours available for vanishing both the tables and the chairs. So maximum it is less than or equal to. Then vanishing the tables and the chairs, we simply add. So this is our fourth and last inequality that we are coming up with from the conditions that we are given. So basically, the 4 inequalities are this one coming from at least 10 tables, then the other one coming from at least 20 chairs, then we have this one from this statement for assembling and vanishing. So we have all these inequalities. This one for assembling, this one for vanishing. In the statement, we are told that each table required 4 hours of assembly, and each chair required 3 hours of assembly. So this is the part of assembling. Then there were 240 hours for assembly. This is for vanishing. We are told that each table required 2 hours of assembly, and each chair required 1 hour for vanishing. So, and the total available time for vanishing is 100 hours. So these are the inequalities that represents the condition that we are given. Thank you very much.